Dear students, welcome and thank you for tuning in. We are continuing our discussion about prototyping in the product design development course. At this video, we're going to start our discussion about the prototyping technologies. We're going to focus on two technologies. One of them will be the CAD modeling and analysis, and the other one will be 3D printing. We will start with the CAD modeling and analysis, which we call virtual prototyping or call it digital mockups. So this is a very important aspect, and students and engineers all over the world are using this technique and technology more and more as it has been developed, and it's getting much more sophisticated. It's about three-dimensional computer-aided design models. It enables many kinds of analysis. To start with, CAD modeling and analysis, so you can see there's a collection of 3D solid entities that can make up your product. So, and those entities, each usually constructed from geometrical primitives such as cylinders, blocks, and holes, and squares and rectangles. So all of them will be combined together and joined together in order to create your prototype and your model. And this is the beauty actually about this technique and this technology, is that we are using primitive geometrical structures, which is very important. Now, there are advantages of using CAD, and these advantages can be summarized by: you can visualize the three-dimensional form of your product, you can see it visually, and also it allows you to create photorealistic images from the model that you have. And you can change the colors, you can change the shadows and the angles that you are taking those photos from. And actually it allows you to automatically compute physical properties such as mass and volume. And depending on what software you're using and what do you want to measure, you can have a wide spectrum of parameters that you can identify. And also the other advantages, there are many advantages, but one of them is also creation of one model from which other focused descriptions such as cross-sectional views and fabrication drawings can be created. Just because you have this model, you just start from this model that you spend time and effort on it, and then you can create multiple cross-sectional views and drawings from this one single model. So those are a lot of advantages actually, and also you can detect geometrical interfaces among parts. So you can see how this part is attached to the other part and what are the components, and detecting these interfaces is very crucial. One of the examples that people keep referring to is that the creation of Boeing 777 and 787 airplanes. So usually in this industry, people, the old days, the company Boeing actually was creating physical prototypes, right? These days, no, they don't do this. They create models and they can extract actually the geometrical interfaces among the parts, because this is crucial in the aviation industry. Now, we said that this is an important, prototyping tool and technique. So you can draw, actually, you can see physical three-dimensional representation and images, but also the analysis is extremely important. So what kind of analysis we can do? So you can do finite element analysis of, let's say, thermal flow or stress distribution or strain distributions. And this is something that you can see here, is where is the stress distributed on the forks here. And then you, in your design, you need to make sure that these parts of your product can actually withstand that load. And this is very important. And also you can have virtual crash testing of automobiles. And this is a very big, and a huge industry actually that is attracting a lot of investment and talent. So you can build the car completely in a model, and then you can do the testing and see how each element will interact and the passengers would behave inside the car. So that's actually another important application or an important analysis. Also, you can do kinematics and dynamics of motion of complex structures. And let's say human motion analysis, you can create a set of equations and you can solve them simultaneously to identify the trajectories and speeds and acceleration of each and every part of your product. So that's also very important. One of the examples that we did, and that's mentioned in the textbook actually, is the PackBot robot, and they've used a lot of simulation and the CAD models and finite element analysis to identify stress distributions if one of the sides, was impacted, was, thrown and fell down and was, hit on the back rear, how would the stress distribution will take place. It's a gray scale, and you can see that there are more stresses here than there, and this is a very good representation of where should the team intervene in their design and make the things stronger, and that to withstand the stresses that the product can experience. I hope this is a good presentation about the importance of the computer-aided design, and that it's very important for manufacturability, form and style, and also there's a lot of different applications, and we hope that in your project you will be utilizing the CAD modeling and analysis. Thank you for watching. Until the next video. Bye.